All right. What's a constructor? Constructors are special methods that initialize the instance variable of a data, where they initialize the data of an object. They have the same name as the class. They have no return type. Okay? They're the only ones that are going to be capitalized because they have the same name as the class. And they're always invoked with the new operator inside the bank account class. So, I'm going to create one here. I like to create it right after I make my instance variables. And that is because I can see them all. They're all kind of in one spot. So I'll say public, no return type, bank account. And maybe I'll put in something that says double val and double account num. This is where the word is very, very, very important. So recall that these have a class scope. So they're alive all the way through while the object is alive. These, they have a method scope inside this constructor. So I must write my balance becomes val. So my balance will become whatever somebody puts in here, 200. Okay? My account number is going to become, that is not what I wanted, is going to become account num. So whatever somebody puts in the parameters here, oh, this was a string, has to be the correct type. Okay? Whatever someone puts in the parameters, my account number or the state of my object will take on that value. If I reverse it, so if I say bal becomes my balance, well, it's not going to give me an error. It's okay to do that. But what's going to happen is my balance after this, because bal is not alive anymore, is going to be 0. It will not do what you want it to do. You want my balance, that instance variable, to become whatever gets passed in by that parameter. Okay? If for some reason you did what I just did and you reversed them, or you don't have a constructor at all, there are specific default initializations for instance variables specifically. They are 0 for numbers, false for Boolean, and null for objects. Okay? So here's a constructor. It's very similar to mine. Okay? But now I'm going to show you another way to make a constructor. Okay? That's using the this keyword. So this is important. It's used within a class to refer to an object you're calling something on. We'll oftentimes see them in constructors. So maybe somebody will put my balance here and my account num here, or my account number. They'll just go like this, actually. So then I will say there we go. My balance becomes my balance. My account number becomes my account number. This is super confusing. How can we have two? Why is it doing this, right? So what this does is it differentiates between the two. I use this when I want to refer to the object I'm on. So something that's not in the parameters. When I want to refer to the instance variable, I use this. Okay? You are going to see it when you read code. So you need to know that this refers to the object that you're on, and when you see it with something like this, my balance, where there's no parentheses here, it's referring to these instance variables up here. The other time we see it is in a dot equals method, okay? So, and we've done this a little bit. So you can see it here in the constructors, and you're also going to see it in a dot equals method, okay? Here's this. All right? When I see it in a constructor, okay, this refers to the checking account object Mrs. Keat, just created right down here. If these are in the client class, okay? So this is referring to my balance, and my balance is going to take 100. So this, my balance, is referring to what's in the parameters. This, my account num, is referring to what's in the parameters. I actually don't tend to use this in constructors because I find it to be a little bit confusing. I just call it something else, kind of like what I just did before, where I had like my balance becomes bal. I feel like it's less confusing, but this is something that is used often, so you do need to be able to read it. Now, the other time I use this, and I do use it very, very often, is actually when we use the dot equals method. And that's, to me, makes a little more sense. All right? So, if I'm going to write a dot equals method, so let's pretend here we're going to write a dot equals method. Two accounts are the same if they have the same account nums. Okay? So, I'll say public boolean equals. And then I will say bank account. So I'm comparing two different bank accounts. I will say if this dot my account number, and remember this is a string, dot equals other dot account number. And to be honest, I can actually just return, oh, I need a lowercase a. I can just return this statement because it's going to give me a true or false. So I could just say return whether or not these two things are equal. There we go. So, what does this mean here? All right, this means here, if I'm referring to it over here. And these, let me stretch this out. I think it wants to be pushed sideways so you can actually see it. I'm sorry, when I formatted this, it was fine. The circle was fine. It got formatted differently when I turned it into a PDF to write on it. So the ones that you have will be clearly formatted in your reading guide assignment. So this says return true. This is covering up return false. But I made two objects. One was Mrs. Keat. One was Mr. Java. Okay, we have a different amount. We also have different account numbers. So what's happening? We're saying, okay, we're going to have a Boolean set. A Boolean is same, and it's going to tell us whether or not these two things are equal. So it's going to return true or false. So what happens? Well, here, this is referring to Mrs. Keat. Okay? And that's to differentiate from other here, which is referring to Mr. Java. So inside this code, the object that I'm calling it on, Mrs. Keat, is this. The object going into the parameter, Mr. Java, is other. So this is so we use the keyword this to differentiate between the two objects. And then is same as false because they have different account numbers. Okay. So we can have what's called overloaded constructors, which means more than one constructor. Maybe you want to set different things. We've done this before. This one right here is just straightforward constructor, but what if somebody accidentally calls a constructor without a parameter? All right. So they're called defaults or no parameter constructor. We want to make sure that, hey, if somebody accidentally tries to create an object without any information, that we can deal with it. All right. So how do we do that? Well, we're going to say public bank account. And then we'll put no parameters there because a user might do that. So maybe we'll say this dot my balance becomes 0. And this dot my account number becomes, maybe I'll say not set. And in this way, it's avoiding us from getting, especially with strings, if this thing isn't set, maybe it'll be set to null. And if it's set to null, maybe it would give us a runtime error and the program would quit. So at least if we set it to something, it will allow for us to actually run the program. The other thing is you might have, like, maybe inside of here, instead of setting the information, maybe you will say, put a print statement. Maybe you'll say system.out.println. You did not enter any information for your account. Please rerun the program and provide the information needed. Okay, so it'll give a print statement in the output window to somebody, and then we can exit the program. So you should have seen that a couple times in your labs. All right, how does the compiler know which one to choose? Well, it'll look over here and it'll say, I'm seeing an error here, so I just want to check on that error. Oh, I need an extra parentheses. So it'll say, you know, do I have parameters? How many parameters do I have? What are the types of my parameters? And then it'll choose this one or this one. Okay, so these are overloaded constructors. And there's an example of 2. We've talked about this before. When we use a constructor, what do? We have to use it to create new objects. We use it in the driver class usually. We can use it in other classes. We'll see it often if we're making a list. We're going to create objects that go into the list. So let's say here, we want to create those 2 different bank account, Mrs. Keats. And then becomes new bank account. Oh. And then, let's see what that information was. 100 and CA124. And then we'll say bank account, and that one should have had quotes around these 2. That was my mistake. But we'll put it in the computer correctly, and I'll fix it. Mr. Java becomes another new bank account. 300, comma, 54, CA 136. So what is actually going on in the computer? Well, the computer is going over here. It's looking to see, okay, well, first, it finds some space here. When I declare it as bank account, it's saying, all right, well, I need some space for that. So what am I going to do? This new operator here finds the appropriate amount of space for this information. That's called dynamic allocation. Okay, and then it actually sets these values and updates the state. Okay, again, here, it's saying, well, when it's declared here, hey, what am I doing? Okay, I'm declaring this. So there's going to be something called Mrs. Keat. And it's a bank account. And Mr. Java. And it's a bank account. And I'm going to go over here on the heap. And Mrs. Keat, it says, oh, this is enough room for this. This is dynamic allocation. What happens when I call the new operator with the constructor. I cannot separate these two when I use them, okay? And it's going to say, all right, well, Mrs. Keat has a balance of 100. And she has CA 124. And then with Mr. Java, as soon as I hit that new, it says, oh, I got to go out here. I have enough space here. I'm going to say Mr. Java has 300 and it's CA 136. Okay, so that's what's called dynamic allocation. Now, you have to have the constructors. They allow you to initialize information for objects when they're created in the heap. Okay, this is important. If you don't write a constructor, the computer gives you one, which is very nice of the computer. Okay, but it will have no parameters, and it will set all numbers and chars to 0, booleans to false, and objects to null. When I say chars to 0, it means whatever value 0 is at. Okay? If you at least write one constructor like we did here, the computer does not give you a default. If you want a default, then you have to create it yourself. So this is also important. If you write at least one and you want a default, you have to create it itself. It's important for us to write a default just in case so that the user won't get an error if they don't enter parameter values. So we're trying to make sure like, oh, hey, what is something that they could do wrong? Well, maybe they won't write parameters. And if they don't write parameters, here's how we can deal with that. Okay, we already started our client class here. Here's our client class. It's the driver class. It's where the main method is, which is right here. Okay, that's where we carry out all our work. So we create our objects. In this case, we create Mrs. Keat, and we also create Mr. Java. Okay, we can call methods. So maybe we'll say Mrs. Keat dot deposit, and we can say 500. And Mr. Java dot deposit 350. Ooh. Now, we're using overloaded methods here. Which one is it using? Okay, Mrs. Keat dot deposit is using this method with an integer parameter because I gave it 500. Mr. Java dot deposit is using the one with a double parameter right here. So if we run this, we can say, maybe I want to put a print line in here so I can show you. I'll say double parameter. And then I'll say int parameter to show you that it's using two different ones. Now, is this returning anything? No. What is this doing? It's just changing balance. So if I were to print out the balance before, here, maybe I'll say system.out.println. Mrs. Keat has, and then remember, I cannot call, like what happens if I try and say Mrs. Keat dot my balance. Or sorry. Yeah, my balance. What's going to happen? Am I going to be allowed to do that? No. Why? Because remember, these are private in here, so I can't access them. So I'm going to say get my balance, because that is the accessor method that allows me to do that. Let me put that there. And let's see if I called it the same thing. Oh, get balance. There we go. Got to make sure it's the correct name. All right. So this is going to give me before I deposit, and this is going to give me after I deposit. So you can see how it worked. So let's give this a run. All right, here's my output window. Mrs. Keat has $100. I created myself with $100. And then it said int parameter because I used the parameter for the int. Then I deposited $500 and it said Mrs. Keat has $600. And then when I deposited for Mr. Java, it used double parameter. Okay, just to show you that it was using the appropriate overloaded constructor depending on whatever I put in the parameter. That's it about objects and methods. This is a huge, it's pretty much the meat of our class. And it's going to introduce us to a lot of cool things that we're going to be able to do later on. There was one last thing I wanted to show you. What happens if I want to show you that both objects, so I'll say Mrs. Keat's routing number. Okay, remember it's public, so I can call it outside of the class. So maybe I'll write bank account dot routing num. And Mr. Java has the same one too. If I update one, I'm going to update the other. Oh. Generally, it's best practice to see, if I try and call that on Miss Keat, it's not allowing me to do so. Why? Because it's static, right? Remember? So I can update it if I want. Well, it's final, so I can't. But static, I need to call it on the appropriate class. So I'm going to run this again. And not on the object. There we go. Mr. Keat's routing number. I should have put a space there, but you get the point. And Mr. Java's routing number.